This tutorial sets up a short-range teleport for the player to be able to move around the map. When initiating it, the player character plays an animation, disappears and reappears at the end of the teleport. You can go through walls and characters with the use of tags, otherwise objects will block the teleport and the distance will be cut short. Behind the scenes, we also adjust the camera not to stagger when going through objects, adding Niagara effects and controlling the animation montage to smooth out the transitions. Alright, so here I have set up a new map. I just changed the colors of everything because I'm tired of the obnoxious green. I have one animation here that I've taken from Mixamo, which is just this jump that we're going to use as an animation for our teleport. And I also have a Niagara effect that just populates pixels around a mesh to be able to create an afterimage effect. I have a link in the description for the tutorial I looked at for that, and so you can make it yourself. But we're going to open up our third-person character. So we're going to get a keyboard event. And I'm going to bind this to F. And we're just going to set up the basic teleport. So we're going to get a capsule trace by channel. And we're going to have to add a bit before this. So I'm going to create a new custom event. And just call it teleport. And connect it off of our keyboard event. We're going to start at our character's location, so get actor location. And we want this to go ahead of us, so we'll get the forward vector. Then we multiply that. Change the pin to an integer. We'll say 500. And add that to our location, and that will be the end. The capsule radius and half height are going to be the same as our capsule component. So we drag that in and get radius and half height. We're going to split the out hit rather than making a new break, just so that it's easier to construct this. If we're just simply going forward, we can set the actor's location. And have it be the out hit and trace. Since it says teleport, you can check the teleport boolean. So now we can teleport ourselves in a direction, but we're able to go through objects, and if the object is big enough, we can go into the object. So we want to make sure that we have it checked to see whether or not we can make it through the entirety of an object. So we can put in a branch after our trace, and have the either the return value or the out hit blocking hit. I'll just use the return value. If this does hit in something, we're going to change the target actor location to something different. So if our trace hits an object, we'll just go to our hit location. And then I'll change the debug to be for the duration. And when we test this out, we teleport forward and we're hitting this wall, so we are no longer going through objects, but we can still continue forward. As to how we can go through objects, there's a few ways that we can do this. You could go through making a trace channel specifically for this capsule trace, but you're going to have to do quite a few traces, and why do many trace when less trace do trick? So if our trace is going and it collides with something, we can take our out hit actor and check to see if it has a tag. So actor has tag. And this only really matters if we do hit something, so we'll get another branch after our true. Then if it does have a tag that allows us to pass through it, we'll go to the end of our trace, Otherwise, we will end at our hit location. We'll be cleaning this up in just a moment. I'm going to create a new tag and we're going to call it pass through. If we copy it, compile it, and go into the level, you can select any object, type in the tag, and under tags we can just add pass through tag here. And in any blueprint, you can add a tag for the pass through rather than changing the channel. So now if we press F, we go right through this. Now we still can go into it, which is another problem to resolve, but first we're going to clean this up a little bit. I'm going to promote the out hit trace to a new variable. And we're going to get it before we get our first branch. And promote the out hit location to a variable as well. We'll assign it when we get to our true pin off the first branch. And we're going to further simplify this to use only one actor location by switching the vector. So we can get select vector. We'll have our trace end be A, and our hit location be B, and then we can promote this pick A variable to a new boolean, and we'll call it open endpoint. To be set as true whenever we would do a trace that does not result in a hit. So we can keep it as unchecked by default. Create a new custom event. We'll call it move to point. Just copy our set actor location. And off of our false branch, we'll drag in our open endpoint and set it to be true. Then we'll call move to point. We'll copy this. And off of our false, connect these pins and then connect true to here. And then we just uncheck the open endpoint of our false, and we try this out again. We're able to teleport through objects with pass through, otherwise we are blocked by any object that does not have that tag. To prevent us from ending inside of an object, we need to get another capsule trace, so we can copy our trace. And we're going to put it a little lower than what we have here because we're going to take this true pin and disconnect it, because if we have an object that is able to be passed through, we need to do this check to see if we can make it through the entirety of the object. We'll remove all the pins. Our start location is going to be our end trace. And you can either have this be ending in the same way, just so that it has one capsule to check to see if our entire actor could fit inside of it, or you can do a trace starting from the end back to the start point. And we want to check to see if our initial overlap is true. That way, if this starts the trace and we are inside of an object, this is going to be true. Otherwise, it's false. So we can copy our open endpoint and our move to point. For true, we do not have an open endpoint. Otherwise, if it's false, then we do. So now if we try to teleport through our object again, now we collide with the wall because we can't get all the way through it. So now that we have the function to be able to move our actor, we're going to go back to our move to point. And we're going to have our character transition from A to B rather than just instantaneously going to the next point. I'm going to take our move to point and disconnect it from our actor location. Then we're going to get a branch. And we need to do something different depending on whether or not we have an open endpoint. If we try to move through an object while we are transitioning an actor location from A to B rather than spontaneously just appearing at the endpoint, we're going to run into some collision issues. So if we do have an open endpoint, and this is only concerning what we set here for our open endpoint, meaning that we're going to be going through a wall. It's not going to matter what we set it if we're in the open air. So assuming that we are going through a wall, we need to make sure that our capsule component has collision turned off. So we'll set collision enabled off of true, and we'll set it to be no collision. Then we're going to set a timer by event. We're going to connect our collision enabled and our false pin to the timer. Our time is going to be 0.01 second looping, and you can do max once per frame. We're going to create a new custom event, and we'll call it vinterp distance. And we'll connect the event pin, and now we can set our actor location. As the event name suggests, we're going to get a vinterp to constant. Our target is going to be wherever we're ending our teleport to, and our start is going to be our actor's location. The delta time we'll say is 1 second, and we can go with an interp speed of 8, and you can adjust it as you see fit. And this timer is going to run until we reach the end of our desired location. And to check to see whether that is the case, we drag off the vinterp value, and we'll get equal, and we'll get our selective vector as well. For our tolerance, we'll just say 2. So if we're close enough, it will end this timer. And when it is the case that it's at the desired location, we will clear and invalidate timer by handle. And just connect in the return value of our timer. And now that that's done, we want to set the collision back to normal. Back to collision enabled. Okay, and we'll test this out. We can go from point A to point B. We can't move around even though we have control. That's going to be fixed when we add our animation to it. And we could still go through objects. Where we still have a weird issue that's going to happen is that we're still affected by gravity. So if we jump, we're just going to sink through the map. So adjusting that with our animations, we're going to go back to the very start, right at our keyboard press. So I'm going to disconnect the pin here, and we're going to add a montage to start this off. So we'll get play montage, drag in our character's mesh, the in-skeletal mesh component. And if you check the link in the description, I have this animation linked. You can also use anything from Mixamo or your own. Just right-click it and create an animontage. and then we open it up. So this has root motion to the animation, and that is what we're going to be using. You don't necessarily have to do it, but it does look a lot better when we have that enabled. I'm going to add 2 notifies. So we can right-click in the notify track, add montage notify, copy and paste. First notify we'll have as start, which will have around frame 10, and the next one will be end, which will have around frame 30. So name the notify start and end. Then in our third person character on the notify name, we'll get switch on name. And on notify begin. We'll get end as the first one, and then start as the second one. On our start, we're going to be connecting in our teleport, but we need to do a few adjustments first. The first thing we need to do is change the character's movement. So then we're not falling while we're doing this. So off of character movement, we'll set movement mode. And we'll duplicate it to just above. Just going to move everything down a little bit to make more room for me. When we start it, we're going to change our movement mode to flying. And then we'll change to falling at the end. Because we're playing an animation over this, our character's not going to go from the falling to landing animation. So now we'll just connect in the teleport. Right, and our character does stay in motion. If it's not doing that after you get the download, just double check that root motion is enabled in the animation. Otherwise, to make this now a teleport rather than just phasing through a wall, we're going to turn our character's visibility on and off. So for our mesh, we'll set visibility. We can leave our start as everything unchecked and select a new visibility for our mesh on the end. So now we have a character that looks more like they're teleporting. If you want to extend the duration of this animation rather than cutting it, since you're playing one montage into another, since we're playing this in an animation instance, which is held in the mesh, we can get our mesh, drag off, and get anim instance. And through this, we can affect the play rate of the montage that is currently going on. So we'll get montage set play rate. And we'll select the montage of our jump. And make sure to connect the target. And we'll change the rate to 0.5. So now when we are invisible, it plays longer, so then our teleport lasts a little bit longer in conjunction with our movement. And then finally, for some special effect, we're going to add a Niagara effect. I'm just going to add a Niagara component. System asset is going to be this after image. So you can either spawn it on top of the mesh, but for this demo, I'm just adding it here. We're going to activate it on our start and deactivate it at the end. And make sure on the Niagara, auto activate is not true. So now we teleport, the character jumps and has this nice little after image. Going through walls can also be a little bit of a hassle, depending on how you want to handle your camera boom. What you could do is, again, drag in your camera boom, and we can set the options on whether or not it should do a collision test. So set do collision test. If we are doing our teleport, select it as no, and then when we end, we'll set it back to the default, which is true. So now if we go through walls, doesn't necessarily shunt. You might want to change the positioning of your camera boom, however you see fit for your own game. Thank you to the pillars of the Patreon for their support: Winterberry Shark, Francesco Poda, and K Panic, and everyone else who supported this channel. If you like these tutorials, want annotated project files from just about everything I've done, or you just want to help me out, you can check out the Patreon link in the description. And of course, feel free to drop into the Discord for updates, to ask questions, or show off your own work to a community of aspiring developers. And of course, I have to ask that if you like this video, let me know by liking the video and or commenting. But that's all I've got for now. Thank you all for watching, and I hope you've been inspired.